Welcome back to another episode of Space Nut.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
I am your host, filling in for the beloved Andrew Dunkley, and my name is Heidi Campo. Joining us today is Professor Fred Watson, astronomer at large. And you are at large. You're still at your conference.
That's correct, yes. It's actually turning out to be rainy Adelaide today. There's quite heavy showers going through, which I can see out of the window. Hopefully I'll get a dry spell to walk up to the university to connect with my colleagues on the conference. I do have an umbrella, so that's all right.
Wow.
Being British, you always carry an umbrella.
I was going to say, you're good at astronomy and planetary science, bringing an umbrella.
Yeah, I should show you my umbrella, actually. I can't do it now, but it's got all the northern constellations on it. It's lovely. You flick it open and suddenly there's the sky in front of you, all marked
so
out, which came from Jodrell Bank in northern England, which is the home of the Lovell Radio Telescope, which is the biggest it was the biggest radio telescope in the world when it was built in 1957. So, yeah.
Wow. Well, that's a fun fact to start off the episode. And I guess speaking of radio, I will brag for us. Before we started recording, Fred had mentioned to me that a story that we just covered on the last episode is hitting the radio with quite a lot of popularity, but you guys heard it here first.
Exactly.
And if you missed our last episode, you should go check that out. But just talking about the big crunch, and we covered it thoroughly on the last episode, and it's the hot news in astronomy now. So you can go back and listen to that one. But we do have a lot of great stories in the queue for today as well that you're also going to want to hear. And, this is funny because it's like, this is a science podcast, but I feel like the articles today are particularly science rich. There's a lot of, and great variety too, Fred. These are going to be some really fun articles. So today, I don't even know. I understand the word bubbles and I understand Milky Way, but I don't know what a Fermi bubble is that we have discovered in the Milky Way. And can you just tell us why they named it the Milky Way?
Oh,
I there's a meme on the internet where it's like, who just looked up at that and thought, milky?
The Greeks, I think, and the Romans. It goes back. It's probably, it's lost in time because it's got this milky appearance. Via Lactea, it's called in Latin, Milky Way. So ancient people looked at it, thought it looked milky, called it the Milky Way, telling it like it is, and it's been known as that ever since. And I think it's delightful that we still call it that. I mean, we see it as it's the edge, the thickness of our galaxy that we're looking through when we see the Milky Way. It was Galileo who first saw that it was made of stars and not congealed milk or something like that. When he perfected his telescope in 1609, towards the end of 1609, early 1610, he saw it was made of stars. And that was the first time anybody knew really what it was made of. And that was, only, 400 years or so ago. So it's quite a recent discovery that it's actually made of celestial objects rather than something almost supernatural, which I'm sure was very much on the minds of people before that. Supernatural milk from supernatural cows, probably. Excuse me.
Yeah, I've always thought, it does, I guess I don't look at it and think milky. I think maybe sparkle way or something. But now that, thinking of it through the lens of ancient people, that makes sense.
A lot of, what you might call First Nations cultures throughout the world see it differently. Here in Australia, a lot of the Aboriginal people, and there are something like 400 different groups of Aboriginal people within Australia. Because it's a big continent and these are small nations dotted throughout. But many of them saw it as a celestial river.
That's great.
And you can kind of get that because often rivers in Australia are milky and the water's sometimes quite milky in appearance. So it sort of all makes sense.
Well, I guess today we're starting off by talking about milk bubbles.
Yeah, well, that's right. Well, that's the froth on your milk, which is very nice on a coffee or something like that. Anyway, that's a different story. So, what are these things? Fermi bubbles. You mentioned them. They and I'm not actually sure. I thought you were going to ask me who named them, and I don't know the answer to that. So I'm very glad you didn't. The Fermi bubbles are they're structures which are thousands of light years across, and we see them in radio telescopes. They're bubbles of hot gas, and we think they're caused by sort of explosive activity in the center of our galaxy, because we know that the center of our galaxy hosts a 4 million solar mass black hole, which occasionally gobbles up material, approaches it and gets sucked into the accretion disk and whizzes around at high speeds, radiating X-rays and things of that sort, and then gets sucked into the black hole. What doesn't get sucked in squirts upwards and downwards at the poles of rotation of the black hole to form jets. That's the way black holes behave. When they're active, when they're gobbling stuff up, they form these jets which come about because of magnetic fields. So we think that the Fermi bubbles are the result of previous outbursts in the galaxy's history. They've only been known for 15 years, Heidi. But,
Wow.
2010, I think they were first picked up by gamma ray telescopes. So that gamma rays are very short wavelength radiation at the opposite end of the spectrum from radio waves, but they are symptomatic of high energy processes. So things that are very hot or very active, like center of a galaxy with an active black hole in it, they're going to produce gamma rays as well. So violent events, they've been likened to volcanic eruptions from the center of our galaxy, forming these bubbles of material moving away from the galactic center. They're both north and south of the center of the galaxy. But some new observations using the Green Bank Telescope, National Science Foundation over there in your country, is a team from, I can't remember which university they're from, North Carolina State University and some other institutions. What they've done is they've used the Green Bank Radio Telescope to get basically really high fidelity images and data on the composition of the gases within them, the speed that they're moving, things of that sort. And that's so they've done what we would call a survey of the Fermi bubbles, and that lets them pick out fine detail. Now, the thing about the Fermi bubbles, as I said, they're very high energy. Their temperature within them is roughly 1 million degrees or so. 1 million degrees Celsius or Kelvin. It's a lot more in Fahrenheit, but it's about 1 million degrees. But there are clouds of gas within those bubbles, which are significant. They're big clouds of gas. They weigh thousands of times the mass of the sun. They're within the bubbles, roughly. The ones they've been identified are about 12,000 light years from the center of the Milky Way. And the amazing thing, given that the temperature of the Fermi bubbles is 1 million degrees, these things are cold. They're, cold in comparison. Let me put it that way. They're only about 10,000 degrees. If you can describe 10,000 degrees as cold, well, it is compared with the 1 million degrees that's surrounding them. And in fact, there's a lovely quote from and one of the authors, the co-author of the paper, is actually at the Space Telescope Science Institute, STSCI, which is in Baltimore. Somebody called Andrew Fox. He has this lovely quote. He says they're around 10,000 degrees Kelvin, so cooler than their surroundings by at least a factor of 100. Finding these clouds within the Fermi bubble is like finding ice cubes in a volcano. And, that's really nice, a nice summary.
Wow.
And you can't, it's hard to understand why they're there. And one of the other astronomers involved with this says computer models of cool gas interacting with hot outflowing gas in extreme environments like the Fermi bubbles show that cool clouds should be rapidly destroyed, usually within a few million years. a timescale that aligns with independent estimates of the Fermi Bubbles age. And it wouldn't be possible for the clouds to be present at all if the bubbles were 10 million years or older. So that's what they're saying is, you've got a scale of a few million years for these things to evaporate, to become at the same temperature as the bubbles. But they haven't done that yet. And one other quote, if I may, because this is full of great quotes, and there's my phone ringing, and I don't know why. I'm going to ignore it. They might be trying to get me out of the room. Do you mind if I take this, Heidi?
Let's pause it.
We'll just. Actually, they've gone. All right.
They'll be back. Don't worry. They'll be back, probably.
They will be back. Yes, I'm sure that's right. Unless the place is on fire or something like that. Doesn't look to be. So another quote on one of the from one of the scientists involved with this. What makes this discovery even more remarkable is its synergy with ultraviolet observations from the Hubble Space Telescope. The clouds lie along a sight line previously observed with the Hubble Space Telescope, which detected highly ionized multi-phase gas. That's just saying it's very excited, ranging in temperatures from 1 million to 100,000 degrees, which is what you would expect to see if cold gas is getting evaporated. In other words, there is evidence that these cold gas clouds are actually dissipating, that they're warming up, and basically they're going to disappear, within a million years or so. So a really interesting story with a lot of loose ends tied up very nicely by the observations made by these scientists.
Wow. That's I'm still wrapping my head around that metaphor of the ice cube in a lava or in a volcano. What an incredible discovery. That's one I'm definitely going to keep my eye on for further, research and seeing what we figure out. This is a really interesting phenomenon.
It's pretty amazing, and Fermi Bubbles. We've talked about them a little bit in the past on Space Nuts, when the beloved Andrew Dunkley was there, and he'll be back, I'm sure. The bottom line is, though, that they're still a bit mysterious. They're clearly they're sort of spherical in shape. You can see when you look at images taken with principally radio telescopes, but also gamma ray telescopes. They're quite spherical. A bubble is a good name for it because they seem to be hollow. But how they actually are, how they arise, probably because the hot gas shooting up from the black hole might excavate a sort of spherical cavern in the surrounding gas. It's still a bit mysterious, though.
3, 2, 1.
Space Nuts.
Yeah. Speaking of mysteries, our next story is also quite mysterious, and it seems like the race is on to figure out what the answer is. And we are trying to figure out, did something just happen to Saturn? Did it just get hit? What is going on? The headlines here is astronomers are racing to find out. So it sounds like this is also kind of a hot discovery that everybody wants to know the answer to.
Exactly.
Is what's going on with Saturn.
So Saturn, I guess everybody's favorite planet with its rings. Wonderful place to study and a great place to start with if you've got a small telescope, because the rings are always quite breathtaking. We know that planets, particularly in the outer parts of, we know planets everywhere are subject to bombardment by asteroids at a relatively low rate. This is part of the process of planet building, most of which took place 4.5 billion years ago. But there are still asteroids bombarding planets that have, missed the boat, really. And we know about asteroids that have hit the Earth, in particular the dinosaur killer back in 66 million years ago. So it's expected that you would see from time to time small asteroids, meteorites, effectively hitting other planets. And the most well-known one for the outer planets is a comet which impacted the planet Jupiter back in, I think it was 1994 or thereabouts, which basically, yes, it was 1994. I've just checked it up. A comet called Shoemaker-Levy 9, which broke up actually because of Jupiter's intense gravitational field. It broke up before it hit the planet, but it did hit the planet, and because people had observed the comet, there were many observations made, including by our Anglo-Australian telescope here in Australia. They managed to observe the impact of Shoemaker-Levy 9 fragments with the atmosphere of Jupiter. And so we'd expect to see the same sort of thing with the other gas giants out there. And so with that as the background, what's hit the headlines at the moment is a flash that has been recorded. It's actually right on the limb of the planet Saturn by an amateur astronomer who was taking video footage of the planet itself. Now, it's an astronomer by the name of Mario Rana, who is a NASA employee and he's, as well as working for NASA, he's also an amateur astronomer. And he basically caught this image, which you can find on the web. There's a few websites that have got a picture of it. It's a very blurry image of Saturn, which is kind of what you'd expect from a short exposure video image, with a flash at one side. Now, the question that everybody's asking, and this is what you were alluding to right at the beginning, is what is the flash? Is it something impacting the atmosphere of Saturn? Or is it perhaps a glitch in the data, which are not unknown at all when you're doing astronomical imaging with any kind of equipment? There's often the possibility of a glitch. So that is a question that can really only be resolved if somebody else was also observing Saturn. If somebody else was also observing the planet Saturn, sometimes abbreviated to Platurn, then you basically, and they found the same flash in their data, then that would prove that this was not a glitch in the data, that it's actually something that's real, a real event. And so the search is on for somebody who was observing the planet Saturn on the 5th of July between 9 a.m. and 9:15 a.m. UTC. That's Coordinated Universal Time. That's the sort of standard time that used to be called Greenwich Mean Time, but is now much more sophisticated. 9 a.m. and 9:15. If any Space Nuts listeners have got footage of Saturn taken at that time, 5th of July, not very long ago, between 9 a.m. and 9:15 a.m. UTC, we want to see your data because there could be evidence that this was a real event rather than a hot pixel or some sort of glitch in the data. So that's a story that I think is going to develop. Again, one we should keep an eye on, Heidi, because hopefully maybe within the next couple of weeks we might find that somebody has recorded the planet Saturn at that time, and that there is a confirmation that it was actually an impacting object. Then we've got to think about what it might have been, possibly a comet, possibly an asteroid, but something big enough to make a significant flash when it actually burned up or interacted with the atmosphere of Saturn.
Yeah. Yeah, this is just another reminder of how important citizen science is, because this is a great example of you don't need to be a Fred Watson to make these discoveries. You could be, any of our regular listeners. You could be a Heidi Campo and still do cool things. And that's really exciting. So I guess we will find out. Right now, I guess it is just a big hands in the air. I don't know. We need more data to figure that out.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
But unlike our last story, where there is just so much conversation, lots of talk, lots of mystery, lots of data, lots of not data, we are talking about, I think we're going to be split down the middle. It's either something you love to talk about or it's, oh man, this again. But we are talking about the search for extraterrestrials.
Yes.
And I think for those of you who are in the camp of you've watched the movie Contact and you loved it, then this will be the story for you.
It's a really interesting story. The reason I put it in today, Heidi, was that one of my colleagues at the conference actually mentioned this idea in his talk for about a fifth of a second. He didn't dwell on it. It was
Okay.
just flashed up on the screen. High energy astrobiology was the term he used. And then he moved on to something else. And I thought those two words, or three words, I guess, high energy with a hyphen in between, high energy and astrobiology. Astrobiology is the study of the origin of life, how life evolved, how it became where it is throughout the universe. High energy astronomy is at the opposite end. It's the stuff we've been talking about with the Fermi bubbles. It's things that are very hot or very active or full of radiation. The kinds of things that you don't associate with the origin of life. That you might, think that these high energy radiations would just destroy any sort of molecules that are trying to evolve into living organisms. And that's why it seemed like, it seemed like the word is an oxymoron, isn't it? An oxymoron's two things that go together that mean opposite things. That's what it seemed like. And then here I found an article which is on the phys.org website, phys.org, reviving search for extraterrestrial intelligence with high energy astronomy. And so it's really it's a white paper actually that's gone to the NASA Decadal Astrobiology Research and Exploration Strategy, and they have a request for information, and this white paper has come in as a submission, and it's got at least two researchers involved with this. They're involved with a project called Breakthrough Listen, which we've certainly talked about before on Space Nuts. Breakthrough Listen is a privately funded venture to devote some of the time on two big radio telescopes, one of which is here in Australia, the Parkes radio dish, to listening for SETI signals. In other words, the search for extraterrestrial intelligence, listening for signals that might actually be somebody's communication signals in a different star system. So these people are already tuned into that idea. Now, the Breakthrough Listen has been going for some years, maybe 15 years. It's funded by a Russian billionaire called Yuri Milner. And they haven't found anything, basically. No signals have been detected that could be artificial in origin. And I think maybe in a little bit of frustration around that, because radio is what you think of at first as extraterrestrial civilizations trying to communicate with one another. It's what we use in our civilization, and it leaks out into space. We know that the Earth is quite bright in the radio spectrum because of all our radio signals as we communicate with each other. So perhaps frustrated at the lack of any response on that, these scientists have posed the idea, how could our high energy astronomy be used to find radio signals from technological civilizations? And it dwells on things like objects that emit cosmic rays, gamma rays, X-rays, all these things which come from sources of high energy emissions. They list a whole lot of them: neutrinos, X-rays, cosmic rays, gamma rays, pulsar wind nebulae, neutron stars, black holes, solar flares, and gamma ray bursts. But how do you associate that with technological civilizations? Well, what you've got to do is think completely out of the box. And one of the boxes that they think out of is, we regard our environment here on Earth at a comfortable temperature of about 15 degrees Celsius on average for the whole planet, as being where life has evolved, where we have evolved. But they are thinking way outside, and they're saying, okay, think of the surface of a neutron star. Now, I meant to look up what the average temperature of the surface of a neutron star is, and I forgot to, but it is very, very hot. It's, we're talking thousands of degrees. And imagine that a life form could exist on such a surface that lives on nuclear energy and all that radiation that comes from the neutron stars. So how do you search the signals we get from neutron stars to look for artificial signals? And they're suggesting AI for that, machine learning, searching X-ray images, neutrino bursts, gamma ray observations. There is a quote, if I may read it from the study, that says, high energy SETI, by and large, must be a commensal effort for the foreseeable future. That's one that everybody joins in. Dedicated programs will only be feasible after much further investigation. At this stage, our efforts will be like those of early radio and optical SETI pioneers who developed methods and infrastructure that took decades to grow into the robust subfield it is today. So, yeah, it's really interesting. I like the other comment as well. An even more basic reason for these studies is the difficulty in building optics for some kinds of radiation, because we cannot make neutrino lenses. Every neutrino detector is sensitive to large areas of sky, making it a good SETI facility if you're looking at the whole sky. But what you find might not mean very much to us. So I'm not quite sure where this study is going. I have to admit a little bit of skepticism as to whether we would ever find a techno-signature from the X-rays coming from a neutron star. It would be very mysterious. So the first thing I would think of would be, well, maybe there's a planet going around it that's got a rather more benign environment to it. But, we're always looking for planets in the Goldilocks zone, that zone where it's not too hot and not too cold for liquid water to exist, because that's the only form of life we know, one that's based on liquid water. But yes, there may be other forms of life. Who knows?
I certainly don't.
No,
Some
no.
of our listeners do. Maybe
Yeah.
Henrik will be the one to find them.
Yes.
This this stuff really does kind of sound like the plot line to Contact. Some billionaire funding, some young ambitious scientist, and I've always laughed because it's like that's every scientist's dream. If someone shows up with a blank check and it's like, all right, how much money do you need? I will fund everything, and you're just like,
Yes.
thank you so
Thank you.
much.
Thank you. Yeah. I know. What do you say? But thank you.
That'd be pretty cool.
Yeah.
My friend, Dr. Alison McGraw, she's a planetary scientist at the Lunar and Planetary Institute. She looks through telescopes, and she's sure her background's in geology, and she's always thought that for extraterrestrial life that we should look for planets with plastic signatures.
Yeah. Yeah.
And that's always been her philosophy, is just looking for those kinds of materials or things that are not going to be organically made. And she's like, we need planets that have garbage on them.
Yeah.
that's going to tell us there's life there.
Yeah, exactly. And it's another way that people are already looking for is, gases in the atmospheres of exoplanets that can only be formed by industrial processes, which might be easier to find than plastic signatures. Some of the gases like chlorofluorocarbons, things of that sort, that only come out of smokestacks in industrial machinery. So
we found that, and it was KB18b.
Yeah, K218b. That's right.
K218b.
Yeah,
close.
Those are the signatures that are reputed to have been found. They still haven't been confirmed. Are chemicals that are only emitted by microbes on Earth. So they're not techno-signatures, but they are bio signatures, what we might call biomarkers, if they are real. So,
and that is an episode from a few weeks ago that we go in depth on if you were interested in that particular planet.
That's the one which your husband likes, I believe.
Yeah, I think he saw that on Instagram and he was fascinated because it was one of those like clickbait type articles that has some headline. It's like, we found aliens. NASA confirms that we have found aliens. It's like, okay, relax. And then you read the study and you find out that they're just finding gas bubbles that might be something. And they're just looking at it through a few pixels on one telescope. So it's like, okay, we're not quite there yet. I think when we do, if or when we do find something, it'll be more than one article from one random Instagram page.
I think you're right there.
Everybody talking about it.
Yeah.
Well, Fred, this has been a really fun conversation, and I know that you're eager to get back to the rest of your conference where you can learn more and share more with us. So we're going to let you get going. But Thank you so much for joining me today. This has been really fun talking about milky coffee bubbles and
Yep. Yep.
Saturn and ETs and all the fun stuff.
A high energy episode of Space Nuts. That's what we call it, don't we? Space Nuts. That's it. Yeah, no, it's
Excellent.
great. Thank you very much, Heidi. Thanks as always, for your time and enthusiasm, and we'll talk again soon.
Hi, Fred. Hello, Heidi. Hello, Hugh in the studio. Andrew again from somewhere in the Mediterranean, where we've spent a fair bit of time since I last spoke to you after our visit to Tenerife. What have we been doing since? Blimey, we've been everywhere, mainly in Spain, but also Morocco. We docked at Casablanca and then took a trip for a few hours to Marrakesh. No, we didn't catch the Marrakesh Express, which is made famous by the Crosby, Stills, Nash & Young song, but we did see it, actually. No, we went to Marrakesh and we sat down to a traditional Moroccan lunch and looked at the countryside. It's a strange change of terrain when you're driving from Casablanca to Marrakesh when you're heading south, because it turns into desert very rapidly, but beautiful country, quite different to what I expected. Then we sailed through the Strait of Gibraltar and saw the Rock. We were supposed to stop there, but delays have forced us to skip the UK territory. And then it was on to Valencia, and we did a cooking class, believe it or not, and learned how to make paella or paella, or whatever is the local pronunciation, and we got to eat it later. Fantastic. And then we moved even further to Barcelona, and we discovered things about Barcelona we didn't know, like the hidden city that was dug up fairly recently. They didn't know was there, but it was a city underneath the city of Barcelona. So they've renovated that and excavated it, and you can see the streets and the shops. They think it was a market called El Born. Worth looking up if you want to check it out. And we saw the cathedral there. I mean, you go to a European city, there's a cathedral, and of course the famous Columbus statue where he's pointing out to sea. Then we moved on again and dropped in yesterday to Mallorca and did a bit of a cross-country trip to see the caves of Drac, and they are spectacular. We even got treated to a wonderful little classical concert with people in boats on a lake in the depths of these caves. And there was an organ, two violinists, a cello and a rower in one boat who did the concert for us. It was fantastic. And then we looked around at many other places. One of the interesting things about Mallorca is in the farming district that we drove across, it used to have a problem with groundwater. It was the ground was completely soaked, and they wanted to use it, and they couldn't figure out how to get the water out. So they contacted a Dutch engineer who came over and said, "Oh, I've got the solution for you," and put up about 2,000 of these windmills and dried the whole thing out by draining off the water through windmills. Well, the windmills are still there, but they don't use them anymore. They use electric pumps instead. And then we moved on today to Cartagena, the one in Spain, not the one in Colombia, although we've now been to both. And we did a little bit of a walking tour around Cartagena, saw the Roman ruins, the Roman streets that they dug up recently, and some of the other architecture, but mainly we were there to try the food, the tapas, and the amazing sangria, and that incredible coffee that they produce with Liquor 43. And, oh, gosh, it's so nice. Probably terrible for my heart, but we'll get over it, I'm sure. So that's where we're up to. Our next stop takes us back to Morocco, where we'll be getting off in Tangier, and then we'll be doing a coach trip to the Blue City. So I'll report on that and more. By the time I talk to you next, we'll have made several more stops. But it's really exciting. We're having a great time. Hope all is well in Houston and Sydney and everywhere else where Space Nuts people live. Talk to you soon. Bye for now.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.